So these problems don't always have to ask for the pH. They can ask for a number of things. So you really got to kind of practice through to see how to do these ones. So you want to take a look at the homework and whatnot. But let's go ahead and take a look at another example of this. So in this example, we have a zero point 0.1 molar solution of some generic weak acid. And we're told that this solution has a pH of 4.25. And then we're asked to find the pKa. So we have to remember that the pKa is the negative log of the Ka. So what we're really looking for here then is the Ka, and then we remember that the Ka is the products over the reactants, and so kind of what we're thinking about here is a rice table, right? It's lots and lots of rice tables. You really want to get familiar with these if you haven't noticed already. So we have our equation, we have HA. You can show with water or without water. It doesn't really matter in terms of acids. So this time I'll show it with water. So it's going to donate its H plus, so it'll turn into H3O plus a minus. Remember, we ignore the liquid, so we're not going to have anything here. We know the concentration of the acid is this 0.1 molar, so we can put 0.100 molar. Again, we're going to assume that the other two values are 0 here, and so we're going to go towards the right direction, so minus x, and then 0.100 minus x, and then x again. And then we can write our Ka is going to be equal to the concentration of H3O plus or H plus times the conjugate base divided by the HA, the original acid. But now this time we're not given the value of Ka, so we don't know what this numerical value is. So let's see what other information that we are given. Let's see, I didn't really use blue yet. So we're told that the pH is 4.25. So let's see how we're going to use this piece of information to figure some of this stuff out, right? So we said that the pH is equal to 4.25, but then we also know some other stuff, right? We know that the pH is equal to the negative log of the concentration of H plus. And so we can take this 4.25, plug it into here. So we've got 4.25 equals negative log of H plus. And so we want to solve for the concentration of H plus because that's what we're eventually going to want, right? Here's concentration of H plus. We know it's equal to X, so then we can figure out X, and then we can figure out Ka. So we need to solve for this concentration of H plus. So the first thing we're going to do is multiply by -1 to get rid of this negative. So it's negative 4.25 is equal to the log of the concentration of H plus. And then to cancel out a log, you have to raise both sides up, or take 10 up to both sides, right? So on this left side, we'll have 10 up to the negative 4.25. And on this side, the 10 up and the log will cancel out. So we'll have concentration of H plus is equal to 10 to the negative 4.25, which you go ahead, plug that into your calculator, and you'll get 5.6 times 10 to the negative 5, right? And so now we can take this numerical value and say, hey, now we know what our X is. Because what we calculated was the concentration of H plus, and the concentration of H plus is equal to X. And so we can go back to our Ka here. We can also say that this is equal to X times X over 0.1 minus X, and then plug in this 5.56 for all of these X values. Go ahead and do the math, and then you should end up with a Ka of 3.1 times 10 to the negative 8. And then if we take a look back, way back to what the heck was our question asking, remember our question was asking actually what the pKa is, not what the Ka is, but the pKa. And so we know that pKa is equal to the negative log of the Ka. And so then we take this Ka value and plug it into here, take the negative log of it, and finally get a pKa of 7.67 as our acid strength.